There we go. Now that should be working. Okay, so Chapter 12, Special Calculations, Calculation of Medications by Age, Body Weight, and Body Surface Area on page 241. And so we have some keywords on page 241. The first one is adolescent. An adolescent is a child from 11 through 21 years of age. Body surface area is a measurement of total body surface area exposed to the environment, calculated from weight and height and expressed in square meters, used as a basis for calculating some medication dosages. Childhood is from 5 to 10 years of age. And Clark's rule is a means of calculating a dose of medication for a child from an adult dose using weight in pounds. Freed's rule, okay, early childhood is from 1 to 4 years of age. And this is according to the American Academy of Pediatrics, and it gives you a website there right under these keywords where you can go check that out if you want to. Freed's rule is a means of calculating a dose of medication for an infant from an adult dose using their age in months. Infant is from prenatal to 1 year of age. Neonate is from birth to 1 month of age. So neonate means literally newly born. A nomogram is a chart. And so we'll show you that chart. It's in here. When we get to it, we'll get to it shortly. Pharmacokinetics is the movement of drugs through the body, including its absorption, distribution, metabolism, and excretion, the ADME. And Young's rule is a means of calculating a dose of medication for a child from an adult dose based on their age in years. So there's reasons why we're going to use one of these calculations as opposed to a different calculation. Okay, so there's a pretest. And then we get over to, we're here, okay. The introduction on page 250. Patients other than adults or average adults may require special medicine dosing. Children are not small adults, but rather a distinct population of individuals that exhibits different pharmacokinetics, the absorption, distribution, metabolism, and excretion than adults. The growth and development of the child, or the focus of the field of pediatrics, significantly affects medication dosing. According to the FDA, pediatric stages include newborn, infant, child, and adolescent. Now, why can't we just say, oh, you're half the size of an adult, let's give you half the adult dose? Anybody?
I don't think your glands will carry, I don't think your glands or your body can sustain it.
Yeah, I mean, the body of a child is different than the body of an adult, not just, you know, a smaller adult. Their organs develop at different rates. And so, you know, they may not have all of the capabilities, especially if they're young infants, of adults. Now, how come we don't know about this? How come we don't do studies on infants and see what they can, you know, what kind of medications, how they work on them?
Because their organs are still growing?
Yeah, that's true. But why can't we still study them? Let's try this medication and see what happens.
I don't know if they have severe.
Baby.
Maribel?
I said in case there's severe side effects, I don't think.
Yeah, there's a lot of ethical concerns, aren't there? Nobody's going to bring you their infant and say, here, try this out on my child. Although this is supposed to be an adolescent. So now you guys know my other weird collection. I collect dolls, especially diverse dolls. So anyway, I was going to let her be my substitute today, but she really can't operate the two computer thing very well. So she just gets to watch today. Her name is Velvet. She's from 1969. Isn't she cute?
Yes.
Thank you. I know some of you are like, what the heck is she doing? Well, you know, so many people, okay, this whole online thing, like my first morning class doesn't even show up anymore. And then I look at my videos that I put on YouTube and they're not even watching them. So I don't know what's going on. And I get emails with questions that were answered in the video. So it's kind of like, you know, frustrating for me as an instructor, especially with the other class. But also, I work with a young man who's going to Valley College, getting all his prereqs for pharmacy. So he's taking chemistry and physics and biochem and biology. And he said he was feeling very unmotivated. And I said, well, I understand that. I kind of feel like that too. Like if I actually log in to do some work, is anybody going to see the work that I do? So I decided to just try and make it a little bit more fun, interesting. And even if I have to act silly and it gets your attention, then, you know, to me, that's worth it. So anyway, yes, I have dolls. And it's fun to have a collection. It's fun to have a hobby. I actually sew for them. For this particular doll, I made her blouse. It really buttons. It has actual tiny little buttonholes, which a lot of times if you have kids, you know, if you buy clothes for their dolls, they have Velcro. These dolls are known for their long hair, and it tends to catch in Velcro and ruin the hair. So I didn't want to use Velcro. So I sewed the pants and the blouse, and I think she looks good in purple. Not everyone can pull it off. So anyway, but her red shoes don't match. I have purple shoes, but they're being worn by a different doll right now. So there you go. Anyway, I'm hoping that you guys stay motivated because we're more than halfway through now. And now we're getting into the hard calculations, or harder than the last, you know, 11 chapters. So I want you guys to stay with me, you know, keep coming to class, keep coming to meetings, and hopefully, you know, get through this, because I really think we're going to be, I already know that we're supposed to be doing remote learning in the spring. Okay, so in the spring, we're going to have to start out this way. However, I'm hoping that at some point we'll be able to go back to in-class sessions, you know, maybe even halfway through the spring. I don't know. It kind of depends on how things go, of course, with the whole public health rates, what it looks like our infection rate is as time goes by. So, I mean, we'll see what happens, right? But
Right.
we just have to get through.
Professor, I'm used to going into class. All of my classes, I've gone into class. So anything I can get online, I take.
Yeah, you know, it works for some people and other people, you know, not so much. So it kind of depends. Everybody's different. I'm getting used to doing this. I like doing this now, but I think this is a good, like, to augment in-class sessions. But I still think that I do better when I have some sort of feedback from my students, you know, because sometimes I actually, you know how you'll say one thing, but you really meant to say something else. Well, I don't always notice that. So I might say, oh, let me write this in this pretty blue color, but it's red. And I don't always notice that. And I have had students in the past who correct me, which I actually appreciate. And if we're not, you know, live together and you view my, my recorded lecture later, then there's going to be like, did she say blue? Wait, it's red. Isn't it red? You know, so it can get confusing. But no, that's just me. I have a tendency to misspeak sometimes. So anyway, thank you for showing up to class, you guys. I appreciate it. All right, so let's look at the rest of this on page 250, geriatric persons. And what does geriatric mean?
Older in age?
Yeah, elderly or older persons. You know what's funny? A geriatric pregnant woman is any woman over 35. Isn't that terrible? Yes. They're considered high-risk elder pregnancies. To me, that's sad because I know so many people who had kids in their 40s. Geriatric persons and persons with organ malfunctions also have differences in pharmacokinetics, requiring the special calculation of many drug dosages. Most individuals with renal or liver dysfunction, renal is kidneys, of course, require dose adjustments. With toxic medications such as chemotherapy, even non-elderly adults with normal organ function may require the use of body surface area on height and weight, based on height and weight for drug calculations. Our hospital uses body surface area, and they also use, they kind of use several different methods of calculations, and they use the BSA for sure, and then they kind of average those together and decide, you know, what dose to give based on that. Emaciated persons, those are people with extremely low body weight or muscle mass, and obese patients may also require dose adjustments for some medications. All these groups are considered special populations because they need special dosage calculations. Since many dosing recommendations are standardized, average adult doses for special populations must be altered, okay? So if you look in your reference book, Mosby's Drug Reference for Health Professions, and you go to any drug, it will tell you what the usual adult dose is. So I'm looking at digoxin right now. It gives you mechanism of action, pharmacokinetics, pregnancy category C, availability. And if you look at the availability, a lot of times if it's available as a tablet, that's usually one dose. So then it gives you, how it's usually given. So it looks at children, because children can use digoxin, adults or elderly, neonate full term, neonate premature, IV dosing, and it's basically 0.125 to 0.375 milligrams per day. So, you know, you look at that regular dose, and most drugs will have you know, like a standard dose that they're going to give an adult with proper organ function who's not elderly and is not obese or starving. So they're going to look at that standard dose for that average person. Okay, so the first thing it talks about is calculating medication doses by body weight. Pediatric doses may be ordered according to the body weight or body mass. The most common method is going to use kilograms. So for example, 12.1 on page 250, it says, what is the weight of a 22-pound infant in kilograms? So now we're going back to chapter 5 where we're converting from one unit to another. 22 pounds is equal to how many kilograms? And then using, you know, either ratio and proportion or dimensional analysis, you're going to get, we want to know how many kilograms. 1 kilogram is 2.2 pounds times 22 pounds. The pounds cancel, and we get 10 kilograms, okay? So let's look at the tech note on the bottom of page 250. It says, because the calculations in example 12.1 are normally going to be included in multi-step conversions to obtain the weight or volume of a dose, it's advisable to practice them using DA, which is dimensional analysis. So, you know, this way you don't have to do a dimensional analysis to get their weight in kilograms, then do another one to calculate how much to give the patient, et cetera, okay? You can do it all in one fell swoop here. Okay, so page 251 gives you even more of that, practice problems. We're going to convert weights from pounds to kilograms all the time. If a patient is in the hospital, a lot of times their computer profile will give their weight in kilograms just because it automatically weighs them in kilograms that way. And then if the parent or the patient asks what the weight is, the person that's talking to them can convert it into pounds, you know, just by multiplying by 2.2, and that'll give them the weight in pounds. Okay, page 252 has a tech note that tells you about setting up a dimensional analysis equation. Let's look at example 12.3 on page 252. A 53-pound child has been diagnosed with epilepsy. The physician orders Dilantin 30 milligram capsules. Capsules are just a capsule that's kind of shaped like an oval. And it's also sealed, so you can't just pull the capsule apart easily. So they actually got the company actually got a trademark on the capsule terminology, which I think is silly. But anyway, so these are capsules. They're to be given at 2.5 milligrams per kilogram per dose. So then we want to know how many capsules should be given per dose. All right, so let's look at how they set this up. They put number of capsules per dose equals, I just start with the capsules, okay? So one capsule is 30 milligrams. And they're supposed to be taking 2 milligrams per kilogram per dose. I don't like to put 2 units on the bottom here, but you're solving for dose anyway. So I'm going to leave that off. And 1 kilogram is 2.2 pounds. So right here, we're already moving into the converting their weight into kilograms right within the problem. And the patient weighs 53 pounds. And I'm just going to put that over 1. Now, if you look at the way this is set up, milligrams on the bottom are going to cancel milligrams on the top. And we like to set this up so that they're sort of like stair steps. You cancel the bottom to the top, then the next bottom to the top, then the next bottom to the top. And the last thing you put needs to be over 1 because it's not already a fraction, but you're just going to make it a fraction. Now you could set this up with these little fractions in any order, except you always want to have the correct thing on top. See, since we're solving for capsules, we need to start with capsules on the top. The reason we set it up this way is so that everything else can, you know, the milligrams can then cancel, the kilograms cancel, the pounds cancel, and then that way we know that we've set the problem up correctly. Does that make sense? So even though you could put these in different orders, like each of these little highlighted boxes, you could transfer them back or forth and it doesn't matter. But we do it this way just because it's easier to remember and know that we've done it correctly. Okay, so now when we multiply the top, we get 2.5 times 1 times 53. I have a calculator here. And I get 132.5 on top. And on the bottom, I get 30 times 2.2, which gives me 66. So then I have 132.5 divided by 66. Which gives me 2.00757575 just keeps repeating, which is going to round to 2.01. So we'll do on my little rounding equal sign, 2.01 capsules per dose. And am I going to worry about the 0.01?
No.
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 I'm not going to worry about that. So we're going to give them 2 capsules per dose. Okay, something like if I were to measure 2.01 milliliters, I might be able to measure that. but I'm never going to be able to figure out how to do 2.01 capsules. I'd have to open the capsule, weigh the ingredients, and then weigh out 0.01 of one of all those ingredients, and it's not worth it for 0.01. Okay, so we're just going to give them 2 capsules. It's the measurable dose. Okay, so we have to have something that's physically measurable. Okay. Okay, let's look at example 12.4. Oh no, let's go to example 12.5 because there's an error in this calculation, which I already told Elaine about, so I want you guys to know about that. It's on page 253. It's example 12.5. A physician orders vancomycin 10 milligrams per kilogram IV, further diluted in 100 milliliters of normal saline. We're not going to worry about the normal saline, to run over 60 minutes Q6H. So we're looking at 1 dose. We're not going to look at how much they would need for all 4 doses, because every 6 hours is 4 doses in 24 hours. After reconstitution, the vancomycin strength is 500 milligrams per 10 mLs. The child weighs 50 pounds. Vancomycin is one of the few drugs that you reconstitute that doesn't have a lot of powder volume. You basically, even if it's a 10-gram bottle, if you want it to come out to 100 milliliters, you pour the 100 milliliters in because it dissolves so completely and doesn't take up a lot of space. There's not a lot of mass to vancomycin. Okay, so the way this order is written, the full 10 milligrams per kilogram is to be given 4 times a day, every 6 hours. So use 10 milligrams per kilogram per dose in this dimensional analysis calculation. So here chapter 12 is where we really get into the author is going to continue to use dimensional analysis, which is why I think it's important that they introduced it way back in chapter, whatever it was, chapter 4 or something, right? Okay, how many milliliters of reconstituted vancomycin should be added to that 100 milliliter bag? 100 milliliters does not count in our calculations. That's just the size of the bag that we're going to put it in. So then it gives you the whole thing. We want to know how many milliliters we're going to add to the bag. So 10 milliliters gives you 500 milligrams. That's your strength of your reconstituted solution. We want 10 milligrams per kilogram, and I already know that's per dose, so I'm going to leave that off. Here's my conversion factor. 1 kilogram is 2.2 pounds, and the patient weighs 50 pounds. And I'm just going to put that over 1. Okay, so do you see how this is very similar to the problem above? You have the strength, 1 capsule is 30 milligrams, or down here, the strength is 10 milligrams per 500 mLs. Up here, you have 2.5 milligrams per kilogram. Here, my dose based on weight is 10 milligrams per kilogram. Right here, I have a conversion factor. Here's my conversion factor here. And then here's the patient weight over here. The patient weighs 50 pounds, okay? So the setup is almost identical. You just have different numbers, right? Okay, so when we do this math, we have 10 times 10 times 50, which is 5,000. And on the bottom, we have 500 times 2.2. Which is 1,100. 500 divided by 1,100, and we get I'm off by a decimal point.
I heard you say 500 over 1,100. Did you divide?
Oh, thank you. See why it's important that I have an actual live student in my class? Because I thought I said 5,000 and clearly I did not. Okay, so 5,000 divided by 1,100. And this is better. This is what I should be getting, 4.54. And the 5.4 keeps repeating. And this is going to be what? What did I solve for? Capsules? Okay, let's see what canceled. Milligrams canceled, kilograms canceled, pounds canceled. What am I left with?
ml.
mLs. So I solved for milliliters. That's how many milliliters I'm going to pull out of that vial of medication. Okay. Oh, look, this one's vancomycin. Okay. So I'm going to pull 4.54 milliliters out of that vial once it's been reconstituted. Okay. Now, what does your book say?
2.27.
Yes, because for some reason, instead of dividing, they ended up getting half the dose, and I don't know how they did that. And Elaine Beal doesn't know either, because when I emailed her, I told her about that, and she thanked me and asked me to send her any more corrections. And I haven't run into a lot of them. I think there were 4 so far that we found in the whole book, which is pretty good, because I have probably 20 pharmacy math calculation books. And I've got, they're all over the house, but there are a ton of them. I actually have like 3 bookcases that I keep these things in. They're not full of math, but you get the idea. They all have mistakes. They all have things that have needed correcting. And usually it's my students who find the correction. This particular one we found when I was teaching this particular problem for the first time. Okay, I don't know how to get rid of that now. So the first time I taught this particular chapter is where we found this out, because I kept thinking I was doing something wrong and I didn't get 2.3 mLs, but it needed to be 4.54, so that was okay. Okay, and now the tech note, not all medications can be rounded to a whole number. Typically, the smaller the dose and the more potent the medication, the less rounding is recommended. So it's important to not round if you get a measurable quantity, okay? So we have 4.54 milliliters, and I'm looking at my syringes. If I have a 5 ml syringe, which I don't, I can see if I'm able to round to 4.54. I have a 10 ml syringe here. And there's 4.5 mLs. So you see the 4 and the 5. I could pull it a little bit past the line, but I want to be careful because I don't want to get into 4.6, right? Okay, so at this point I'm rounding. This came with a medication that we got the other day, and I liked it because the inside is red, so it's easy to see. And I told Professor Glennie, hey, I want to take this home and use it in a Zoom meeting. And he started laughing and he said, yeah, that's a great idea. And I said, do you want one? Because it came with 2. And he said, no, I don't teach math. You go ahead and do that. So he gave me both of them, which was very nice. We're very collaborative over here at Valley College. Okay, let's look at these tech notices. Not all medications can be rounded. The tech alert, be sure to read orders carefully to distinguish whether medication is being ordered per dose or per day. Okay, because a lot of times they'll calculate how much they should get per day and then realize that the drug lasts, say, 6 hours. So if the drug lasts 6 hours and they don't want it to get out of the patient's system, then they're going to order it 4 times a day or every 6 hours, right? So we want to make sure that we don't give them a whole daily dose every 6 hours, because then they're going to get 4 times the amount of medication they need, right? Okay, so the next few practice problems are doing that, and it also gives you practice on using the household system to see how much you're giving the patient. Okay. So that is just calculations by kilogram. Now let's look on page 259 at Clark's rule. Okay, so the way I remember this one is Clark is really worried about his weight. And that's because he's Clark Kent, and Superman can't, you know, appear to be fat, right? Because it's Superman, he has to be, you know, buff and thin. So I remember that one is based on weight, and we're looking at the child's weight in pounds because, you know, here in the US it's easier. They probably have a Clark's rule in Europe that they use using kilograms, but our textbooks here teach us to do this in weight, and it's easy because it's just 150 pounds. Clark's rule is a method for approximating pediatric doses based on the manufacturer's recommended average dose by relating the child's body weight to an average adult's body weight. The assumption with the formula is that the average adult weighs about 150 pounds. Because studies of body weight of adults have shown that the average adult now weighs more than 150 pounds, Clark's rule is being phased out as a means for calculating pediatric doses. However, technicians should still be aware of this method. I have seen doctors and pharmacists use Clark's rule, and it does appear on our national exam, so we really do need to learn it. I think this blue is a little bit too light. You go with a little bit darker blue. Okay, here's our tech alert though. The pediatric dose recommended by a manufacturer should always be used if they have a pediatric dose. But remember, some drugs, they're not going to study them for their use in children. So you won't always get a pediatric dose. Okay, so Clark's rule is the child's weight in pounds divided by 150 pounds times the adult dose. And that's going to equal the child's dose. Okay, so if we look on page 260, it says in the tech note that the answer obtained is always an approximation. Okay, and underneath it, the tech alert, Clark's rule would never be used to determine the dose of a medication with a narrow therapeutic range. Okay, so remember we talked about the therapeutic range is the amount of drug that makes it effective and then the amount of drug that makes it dangerous. So right in between is the therapeutic range. Now, some drugs are only effective at a certain dose, but if you go too far past that dose, it becomes toxic. So those drugs are said to have a narrow therapeutic range. Okay. So if it has a narrow therapeutic range, that's when we would look at dosing in milligram per kilogram. So example 12.6 says a physician orders Cefzil for a 38-pound child with an upper respiratory infection. The adult dose for Cefzil is 500 milligrams every 24 hours. And this is a drug that they usually only give, they only give it once a day on this one. So we don't have to worry about dividing it by how many times a day they're supposed to get it. And then it says, because the physician did not order an amount per kilogram of body weight, calculating this medication by milligram per kilogram body weight method is not possible. How many milligrams should be given for one dose? So the child's dose is the child's weight, which is 38 pounds, divided by 150 times 500 milligrams, which is the adult recommended dose. Okay, so 38 divided by 150 equals times 500 equals, and I get 126.7 milligrams. Okay. Does that make sense, you guys?
Yeah.
Okay.
Yes.
And then it says if the prescription is filled with Cefzil 125 milligrams per 5 ml, how many milliliters are needed per dose? Okay, so we already know this is one dose because they're only getting one dose in 24 hours. What's going on here? I love when it moves over and I didn't tell it to. There we go. Okay, so the strength of the medication is 125 milligrams per 5 mLs, but I want to know how many mLs to give, so I'm going to put the 5 mLs on top. 5 mLs contains 125 milligrams times 127 or 126.7 milligrams, because that's how much I want to give the patient. And I'm going to put that over 1. Now your book calls that over 1 dose, and that's fine. So 126.7 times 5, and I get 633.5 over 125. And that gives me 5.068 milliliters. Okay, this dose should be rounded to 5 milliliters, which is a measurable amount. Okay, and this is already an approximation due to the use of Clark's rule. So since this is an oral suspension that we're sending home with a patient's parent to give to the child, we're not going to ask them to try and measure 5.068 milliliters. We'll just give them a 5 ml measuring spoon and let them use that. Okay, now personally, I like to go to Young's rule and Freed's rule next because they're all based on age and body weight, okay? But your book takes you straight into body surface area. So what we're gonna do is we're going to skip over to page 268, and then we'll go back to body surface area. Page 268 is calculating medication doses for pediatric patients based on age. Okay, so we're calculating this based on the patient's age. Ooh, let's go purple. Pediatric doses have also been estimated by age by using Freed's or Young's rules, which are based on the normal adult dose. These also yield approximate answers, okay, and should not be used with medications with that narrow therapeutic index. Age is no longer considered a valid criterion for determining pediatric dosing, but a technician should still be aware of the following formulas. So what they usually do though is they go ahead and use it and they compare the dosing by weight, by age, and by body surface area, and they'll usually get a number that's very close to like an average of all those doses, okay? So they do like to do all of this because they cover the bases, and it's also going to be on a lot of national exams. Okay, so Freed's rule is used for infants up to 12 months. Okay, and they're figuring that the average adult is 150 months. So let's see what that comes out to. 150 divided by 12, it gives you 12 and a half years. So they're thinking that by 12 and a half years, most kids are pretty close to an adult size. So I think that's what they're thinking of there and also as far as organ development at 12 and a half is pretty much like an adult's organ development. Okay, so the Freed's rule, this calculation is the age in months divided by 150 times the adult dose is going to equal the infant dose. And this is Fried's rule, F-R-I-E-D. It kind of looks like fried to me, like fried foods, but I believe they pronounce it Fried's. Okay, so then it gives you an example, 12.9. A physician orders amoxicillin for a 6-month-old infant. The usual adult dose is 500 milligrams, and this is per dose. How many milligrams should the infant receive per dose? So the infant is 6 months, so they're going to take 6 divided by 150 times the adult dose, which is 500 milligrams. And then we end up with 6 times 500 equals divided by 150 equals, and we get 20 milligrams. And then it wants you to calculate the dose in milliliters to give the patient. If the medication available is amoxicillin 50 milligrams per milliliter, and this is a common amoxicillin for infants, then what dose would be needed to be given to the infant? So it's 50 milligrams per milliliter, which means that 1 ml contains 50 milligrams, and we want to give the patient 20 milligrams. 20 divided by 50 is 0.4 milliliters. And then you have some practice problems for that, but also let's look at Young's rule, and this is right underneath the amoxicillin. Young's rule is based on age because you know, the word young indicates age. So that's how I know the difference between Clark's rule and Young's rule, okay? So Young's rule is used to calculate medications for children from 1 year of age to 12 years of age. And Young's rule is the child's age in years divided by the child's age plus 12. Times the adult dose. Okay, so looking at example 12.10, and this one's Young's rule. A physician orders amoxicillin for a 5-year-old child. So we're comparing amoxicillins here between this infant and the 5-year-old child here. The adult dose is 500 milligrams per dose. What dose would be given to the child? So the child is 5. Let's divide that by 5 plus 12. 5 plus 12 is 17, right? So 5 divided by 17 times 500 milligrams, which is the adult dose. So 5 divided by 17 equals times 500 equals, and I get 147.06 milligrams. Now this comes as a suspension 400 milligrams per 5 mLs. If we don't round the milligrams now, we can round it later when we do our milliliter calculations. Okay, so don't worry too much about that 0.06 at this point. Just leave it in there. So it's 400 milligrams per 5 ml. Now you see the one that we gave the infant was 50 milligrams per milliliter, right? Because that's an infant bottle of amoxicillin. This one is stronger, so it's 400 milligrams per 5 mLs. So if 1 ml contains 400 milligrams, and we want to give the patient 147.06 milligrams.
Professor, I think
yes.
it's 5 mLs per 400 milligrams.
Thank you. You are correct. Very good. It's 400 milligrams in 5 mLs. You guys, is this an injectable or an oral solution?
I think it's oral solution.
Okay, Maribel, why do you think it's oral?
It says suspension. Isn't that what that means?
Because in the mold, maybe if it's for injection, should be in unit.
Okay, so there's a couple of clues. It says suspension. There are some injectable suspensions, but they're really thick and they kind of hurt when you inject them. Also, you know, we don't usually inject amoxicillin, we inject ampicillin, so that's another clue. But if you don't know all of that, look at the way it gives you the amount, 400 milligrams per 5 mLs, right? 5 mLs is a teaspoon, yes?
Yes.
Okay, so if it's a teaspoon, you're not going to inject it, right? So the big clue here that this is an oral is the 5 mLs. Yeah, because it comes as that listed as its strength. Okay, so that's a clue. Okay, so 5 divided by 400 equals times 147.06 equals, and I get 1.83825, which they've rounded to 2 decimal places. So it's 1.84 milliliters. Okay, so the measurable dose that this particular problem says that you can get is 1.8 milliliters. So if you look at an oral syringe, you'd use a 3 ml oral syringe for this one. And I don't have one here with me right now. So it's going to be 1.8 or 3 little marks past the 1.5 line. Okay, so that's Freed's rule, Young's rule, and Clark's rule. And this is based on weight. Clark's is weight. Freed's and Young's are based on age. So now let's look at the more complicated one, which is body surface area. So if we go back to page 261, the other thing that I told Elaine Beal about when I emailed her, because I'm very gutsy. The older I get, the more gutsy I get. I've never emailed the author of a textbook or a book before, for that matter, because it just wasn't important to me. But I love this book until I got to this point and I went, wait, where's the equation? She gives you the nomogram, but she doesn't give you the equation. That drives me nuts. I want to know how this nomogram works. What is it doing on page 262? So let me give you the equation that these nomograms are based on. Okay, so it's body surface area, and there's 2 of them. So what they're doing is they're taking the height and weight, multiplying it together, dividing it by a constant number, which they came up with scientifically, I don't know how, and then they take the square root of it. Okay, so those of you who are really into math, you're gonna love this one. And it's okay if you wanna use it without using the nomograms. I'm okay with that, just so you know. The one that is standard, or we would use in the US, although we're using more metric, is the square root of the height in inches times the weight in pounds divided by 3,131. So there's the standard, and here's the metric, which actually comes out to just about the same thing. Square root of the height in centimeters times the weight in kilograms divided by 3,600. I cannot write today. It's okay. So we have our standard, or the non-metric version, and then we have the metric version. Okay, so the standard one uses inches and pounds and this constant, And the metric one uses centimeters and kilograms and that constant, okay? So if you look at your nomogram and then play with that equation, you should come up with a very, very similar amount. Okay, so now let's look at this nomogram. So I have my book open to the nomograms. The nomogram is just a chart, okay? On page 262, it gives you the one for children, and it gives you right in the middle for children of normal height for weight. Do you guys have your book open to 262?
Yes.
Okay, so you can see the nomogram, right?
Yes.
Do you see in the middle the little box right underneath the word nomogram? There's a box that says for children of normal height for weight.
Yes.
I'm not exactly sure why that's on there, because what is normal height for weight? Which you know, whose standards are we using? It's kind of weird. But anyway, there's going to be questions in here that ask about that. So what you do is you take a straight edge. It could be a ruler, or it could be a, you know, an envelope piece of paper that you fold in half, whatever. Let me see if I can get you guys to see this. Are you able to see that a little bit? I think it's real close to the book. And I'm going to find the height on one side and the weight on the other side and line them up and move my straight edge until I find what I'm looking for in the middle, where it says SA meters squared. Right next to where it says for children of normal height for weight, we've got this SA.
Yes.
Okay,
You
so
can
that's
pull
how
your
we do
book
it.
towards you, Ms. Lopez.
What's that?
Pull your book towards you so I can see better.
Yeah, this is really hard to see. Let me see if I can show you this way. So for this one, you're going to line up the height with the weight and find where they cross. Okay.
So we need to look the cross at SA.
Yes, where it says SA in meters squared.
Okay.
Okay.
Okay, so you're holding the ruler horizontally on the paper there?
Yes, so you're going to hold your ruler horizontally, and it's not going to be straight across. It might move, you know, up or down depending on what, you know, where your height is compared to your weight.
Got it. Thank you.
Okay. So if you go over to page 263, there's a nomogram for calculating body surface area for an adult. So depending on your problems in this part of the book, you might use the children's nomogram or the adult nomogram, or you could use the calculation I showed you here. So either way, you know, and I don't care. If you use your calculations here, you're going to get almost the exact same answer as the key in the book. Okay. And then on page 264, it recreates the nomogram on page 262, but in red, they've highlighted the part that says for children of normal height for weight. Okay. And it shows you a line connecting someone who is like 43 or 42 inches tall and who weighs 35, 36 pounds. Okay. So it shows you that, and it crosses at the 0.68 or so. Okay, so you already see the way these nomograms are set up, they're not going to be exact, right? Because you're going to have to estimate how far between the two numbers or the two lines is my number.
Yeah.
Yeah, so it's kind of, you know, it's a tool. I think they made it up because they didn't want people to have to do these calculations all the time. That's my theory anyway. So using the proper nomograms for practice problems D, calculate the following body surface area as practice round to the nearest hundredth. So how many decimal places is the hundredth?
2.
2 decimal places. Okay, so you know what I'm going to do? I'm going to look at number 1 where it says a child weighs 15 pounds and is 24 inches tall. And since it's in standard, I'm going to use this, my calculation for it, my equation. So if they're 24 inches tall and they are 15 pounds, so I'm going to take 24 times 15, divide it by 3131, and then take the square root of that. Now, most of us have a calculator with a little square root button. Mine's up here in the corner there. Yeah. So the way I'm going to punch it in my calculator is 24 times 15 divided by 3131, and then hit the square root button. So that's exactly how I'm going to calculate this. 24 times 15 equals, divided by 3131 equals, and then hit the square root button, and I get 0.3390858, which is going to be 0.34 meters squared if I go to the hundredths place, right? Okay, so now if I use the nomogram back on page 262, and I'm going to look at the height in inches, which is on the left side of that children for normal height for weight, and I'm looking at 24 inches, and then I'm going to go up to 15 pounds, which is on the right side. And as you move the right and left side, sometimes one side wants to move also. And then my surface area in square meters is right at 0.35.
Yes, 0.35.
Okay, now is that in the hundredths place that it's different?
Yes.
Yeah, it's only different by 1/100th of a square meter, right? So
Yes.
I don't think it matters which way you use. The book uses your nomogram, okay? You can use the calculation if you would prefer. I did request that Elaine Beal include these calculations in her next edition. I don't know if she's going to, because, you know, we're not really besties. So like I've never met the woman. She lives way over in the East Coast somewhere. Okay, so it gives you those practice problems to calculate the body surface area. And then it gives you, it goes into then the other rules. Page 266 gives you some practice problems E. So let's look at 266 number 1. And it says a child is 25 inches long and weighs 15 pounds. The physician orders Lanoxin, generic name is digoxin, elixir daily. The adult dose of Lanoxin is 0.25 milligrams per day. The available medication is Lanoxin Pediatric Elixir, 0.05 milligrams per milliliter. Okay. Does this problem tell you how many milligrams per square meter?
Per what, please?
On number 1, does it tell you the milligrams per square meter?
No.
No.
No. So can you use the body surface area?
Yes, we can.
No, because we
No.
only know the usual adult dose. We don't know how much per square meter.
Okay.
Okay, so you can find the child's body surface area, but you would have to use one of the other problems to estimate that, if you wanted to estimate using one of the rules in this chapter, or per milligram per day. So this question is going to be really difficult, isn't it? because it doesn't tell you how many, how much to give them. The only thing we could do, because we don't know how old the child is, but how, is the child weighs 15 pounds, right? So we don't know if we should use Young's rule or Freed's rule. Freed's rule is used for children up to 12 months, right? Does this child could be an infant, right? At 25 pounds, 25 inches long and 25 pounds, or 15 pounds, I mean.
15 pounds, yeah.
Yeah, it could be an infant. Okay, so this problem, because it tells you calculate the following based on body surface area, this particular practice problem seems to be an issue, and I need to mark it because I know I noticed this last semester, but I didn't mark it.
So we will consider the child as infant here.
This problem can't be done based on the BSA. So I would ignore this problem. Now, if you wanted to calculate it using Freed's rule or Young's rule, you could. And then what would the daily dose be in milligrams and what volume of medication would be administered? Okay, hold on a second. Okay, I see what they're doing. On page 265, it gives you another example, okay? About halfway down, page 265, it's right above where it says example 12.8. It says, if a medication for a child is not ordered in an amount per square meters, a formula similar to Clark's rule may be used to calculate the dose. The normal BSA of 1.7 square meters for adults and the normal adult dose may be used to estimate the child's dose. After using the nomogram for a child, the following formula may be used for calculating the dose. So that's the child's body surface area divided by 1.7 square meters, which is the normal adult BSA. And I don't know if I would use normal. I think it was only the average back when they figured this out. But anyway, that's going to be times the adult dose. So going back to page 266, number 1, it wants to, let's use this formula. Now we can figure it out, right? So
Yes.
What's the child's body surface area? So we go back to the nomogram and we're looking at 25 inches and 15 pounds. So 25 inches on the left side is right in between the 24 and the 26, and 15 pounds on the right side is right between the 14 and the 16. And what do you get there?
Also, I think 0.35.
Yeah, I think I get 0.35. Or you can use this calculation, the standard calculation if you want to. So 0.35 divided by 1.7 times what?
Adult dose. Where's the question?
So back on 266, what is the adult dose?
0.25.
0.25 milligrams. Okay, so when you're doing a calculation where you have a fraction and you have a number that's not a fraction, it's assumed that the number that's not a fraction is over 1, right? So you can do the top times the top and then divide by the bottom. Or you can do the bottom divided by the top times the top. Okay, so I could do 0.35 divided by 1.7 and then multiply it by 0.25. Or I could do 0.35 times 0.25 and then divide by 1.7. You're going to get the same answer either way. Okay, so let me plug it in my calculator. I'm going to do the 0.35 divided by the 1.7 first, hit equal, and then times 0.25. What do we get?
.05.
Yep, and since we're rounding to the hundredths place because they didn't tell us to do anything different, we're going to get 0.05 what?
Milligrams per day.
Milligrams per day. Good. Have you ever had a problem that's really long and complicated and you plug all your numbers in and you get to the end of it and you go, wait, what did I just calculate?
So Professor, are we not using the meter square, like the formula?
Yes, because this, the 0.35 was the meters square.
Okay,
And we're dividing it by 1.7, which is the normal body surface area in meters squared. Okay, so we don't have to use this formula unless you want to. Okay, if you're somebody who's, you know, looking at your straight edge in your book and you're like, I can't read this thing, then plug in the formula. Okay, on the other hand, if you really don't want to do math, then do your ruler, you do your straight edge on the paper, okay, and use the nomogram.
okay,
Okay, was that your question?
yes.
Okay, good. Okay, so what's the daily dose of lanoxin in milligrams for the child? That's 0.05 milligrams per day. The child's BSA here was 0.35 square meters. And what volume of medication would be administered per day? So then we have to go back to the available medication in lanoxin pediatric elixir is 0.05 milligrams per milliliter. So what volume would we be giving the patient?
I think 1 ml.
Yeah, 1 ml, because you're going to get that
The same.
0.05 milligrams
Yeah.
in 1 ml.
Ml, yeah.
And we could go ahead and calculate it out. 0.05 divided by 0.05 equals 1. So there we go. Okay, now, some of these problems, like number 4 gives you normal height for weight. Number 3 gives you kilograms and centimeters. So if you were going to use a calculation for number 3, you would need to use the metric formula, right?
Right.
Okay. If you wanted to use a nomogram, you're going to be looking at kilograms and centimeters, or centimeters and then kilograms from left to right. Okay. There are a few problems I've seen just to throw you off, and you might find these on your national exam, where it gives you the height in inches and the weight in kilograms. So if that happens, you want to be careful on your nomogram that you're lining up inches on the left and kilograms on the right, because that's very common in the US. We've finally gotten used to using kilograms, but good Lord, we don't know what a centimeter is, right? So this happens quite often. You know, you'll get the weight or the height in inches, but the weight in kilograms. So be careful on those. And I haven't seen one on this book yet, but I have seen it in other study guides, okay? Practice problems and things.
Mrs. Lopez, can we convert like inches to centimeter or kilograms to pounds?
Exactly, yes. Yes, you most certainly can. And especially if you're using the calculations, then you're going to need to convert either to all standard or all metric. So you're either going to convert the centimeters to inches, or you're going to convert the pounds to kilograms. Okay, depending
Okay, thank
on
you.
what you get, right? Okay. If they give you pounds but centimeters, then you would have to convert the other items. So, you know, if you have mixed, you know,
Units.
mixed types of measurements, then you're going to have to convert them all to one thing in order to do the math. Now, if you wanted to use the nomogram, just make sure that you're looking at the correct either centimeters or inches, and then the correct either pounds or kilograms, okay? So I just like to throw that out there because sometimes, you know, you'll get these, this is the best study guide for your exam, and then you open it up and, you know, they are some hard problems at the end of that. Okay, let's look at page 267, number 6. Okay, come here, you. Let's go with dark green. A child who weighs 20 kilograms and is 114 centimeters tall, so that's about 44 pounds, right? And has a BSA of 0.8 square meters, has an order for Demerol. Demerol is meperidine. By mouth, every 6 hours, PRN, severe pain. The usual adult dose is 50 milligrams every 6 hours. The medication is available as 50 milligrams per 5 mLs. So this is liquid suspension meperidine by mouth. And that's why it gives you the 5 ml availability there. Okay, so we have the height in centimeters, we have the weight in kilograms, we have their BSA, we have the usual adult dose, and we have the availability. How does this drug come? So what dose should be administered to the child every 6 hours? This doesn't give you their age, so we can't use Young's rule or Freed's rule, but they're also not an infant because they're, what's 20 times 2.2? Is that 44? Yeah, it's 44 pounds, so it's not an infant unless it's a huge infant. And it does give you the BSA, so we should probably use the body surface area, right?
Yes.
Okay, so it does not tell you how many milligrams per meter squared. Okay, so we can only do the one where we divide it by the average adult BSA, right?
Yes.
Okay. So what dose should be administered to the child? Okay. 0.8 square meters divided by 1.7
1.7.
times the usual adult dose, which is what?
50.
50 milligrams. So I'm going to round the 0.52 up to 0.53 because the number after the 2 is a 9. So 23.53 milligrams. And then it says what volume should be given to the child per dose. Did you guys get this 23.53 also?
Yes.
Okay. and the medication is available as 50 milligrams per 5 mLs. How am I going to set that up?
I think it's almost like the half of 5 ml, so it's almost 2.5, almost, or 2.4 ml.
Yeah, I love that you estimated first. That is exactly right. It's the usual adult dose is 50 milligrams, and it's 50 milligrams in 5 mLs, but we want to give a little less than half of that, right? Half of it would be 25. So we know we need a little less than half. So we know our answer is going to be a little less than 2.5 mLs. So let's go ahead and calculate it this way. 5 mLs gives me 50 milligrams, and I want 23.53 milligrams. And I get 2.353 milliliters, or 2.4 milliliters, 2.35 or 2.4. Okay. You might be able to measure 2.35, but even on a 3 milliliter syringe, you're going to get just real close to 2.4. Okay. Let's see if we can find a problem in here that tells me milligrams per body surface area, milligrams per square meter.
I think 9, does that look like one?
Yes, let's look at number 9 on page 268. An adult with a BSA of 1.62 meters squared has severe herpes zoster. What is herpes zoster? Is that like genital herpes?
No, I think it's like shingles.
Yes, it's shingles. Very good. Shingles is caused by the reactivation of what virus?
Chickenpox.
Chickenpox, yep. So when a child or even an adult gets chickenpox, the virus stays in their system for the rest of their life, and it hides in the nerves that come out from the spine, and it travels down to the nerve endings, and it stays there. And then when a patient gets severely stressed, it can reactivate, and it can cause a severe, extremely painful rash. When I was in high school, my mom had an attack of shingles, and it started on her left shoulder blade. It came all the way over her shoulder and all the way down her left side to her waistband. And she had to take about 3 weeks off of work. That's how bad it was. I believe for 2 weeks, the first 2 weeks, she basically tied a sheet over her right shoulder, and she held it up in front of her because she couldn't stand it to touch her skin, but she didn't want to walk around, you know, topless. It was very sad. I was a junior in high school when that happened, and I felt so bad for her. So this is extremely painful, and they do have antiviral drugs that they use to treat it. One of them is Zovirax, which is Acyclovir. Another one they can use is Valtrex, which is Valacyclovir. So these are antiviral drugs, and it shortens the duration of it. So this patient is 1.62 square meters, and the physician orders this drug at 500 milligrams per square meter every 8 hours. And Zovirax is available in 400 milligram tablets. So what dose of medication should be given to the patient every 8 hours? Okay, so it doesn't tell you what the usual adult dose is, right? Because they're already an adult. So we're going to calculate this by per meter squared. So we want to know how many milligrams, right? $500 milligrams per 1 meter square, or per meter square. The patient is 1.62 meters squared. Yeah. What do you guys get for that?
I got 810 milligrams.
810 milligrams. Okay. So it even asks you how many whole tablets should be given to come closest to this dose.
2.
2.
Yep. 1 tablet is 400 milligrams. We want to give them as close as we can to 810. .025 tablets, and we're going to ignore the 0.025. So we're going to give them 2 tablets per dose. Okay, let me see what our drug reference says on acyclovir. They're using acyclovir for a lot of other viral medications. We use it a lot in Children's Hospital. Okay, acyclovir. So it says herpes zoster shingles by mouth, adults, elderly, children's 12 years and older, 800 milligrams. This is every 4 hours or 5 times a day for 7 to 10 days. And it doesn't give me the milligrams per square meter because this isn't necessarily a drug that you would use that type of dosing for. Children younger than 12 years old would be 10 milligrams per kilogram every 8 hours for 7 days. So it's a good thing to know. Okay, so I like number 9. It does give you the milligrams per square meter. And number 8 is a drug that they do dose using body surface area quite often. An adult with a BSA of 1.78 square meters has been diagnosed with a malignant neoplasm. The doctor orders Oncovin, generic name vincristine, 1.4 milligrams per square meter intravenous. Oncovin is available as 1 milligram per 1 ml. Okay, what is a malignant neoplasm?
Is that a malignant tumor?
What's that?
Is it a malignant, so cancerous tumor?
Yes, it is. Malignant, of course, is cancerous, and a neoplasm literally means new growth, so it's a cancer. And vincristine is used quite often for certain types of cancers. So if you guys want to work on that one, then we'll see what you get.
I'm sorry, Ms. Lopez, what number was that?
Page 268, number 8. It's the one right above the one we just did.
Okay, thank you.
So there's just two calculations here. You want to calculate how many milligrams they're going to need based on their body surface area, and then what volume based on how the drug is available, right? Did anybody get an answer to it yet?
No.
What did you get, Maribel?
I got 2.268 milligrams. And then when I go ahead and do the 1 ml over 1 milligram times 2, I rounded it up to 2.3 milligrams.
Okay,
Basically, it's 2.3.
okay. Okay. How did you get their body surface area? I mean, how did you get the milligrams?
No, the body surface area is 1.78. Where is that again? Oh, I think sorry.
Okay, so the body surface area is 1.78. And I'm going to multiply that by 1.4 milligrams per square meter. Okay, so if I want to use a dimensional analysis, I'd put the 1.4 milligrams over square meters and then times 1.78 square meters, not milligrams. This is going to be square.
Yeah, it's my bad. I was looking at the wrong BSA, so I miscalculated that.
Oh, okay. You were looking at 1.62, right? Yeah.
I get 2.492.
Exactly. That's exactly what I got. So I get 2.492. And then since it's 1 milligram per milliliter, 1 milliliter gives me 1 milligram. And I want to give the patient 2.492 milligrams. It's going to give me 2.492 milliliters. You guys, if you can survive my handwriting, you can totally survive pharmacy tech or nursing school, seriously. So what would we round that to? If we want to go to the hundredths place, what am I going to end up at? Wouldn't you end up at 2.49 milliliters?
Yes. Now, is that a measurable in ml? Can we do 2.5?
Yes. Yes, because if you use a 3 ml syringe, there is a mark at 2.49. There's a mark at, let me see. Going back to this chapter here, not that one, the one before it. Okay, on page 216, the pretest for chapter 11, where it's talking about anticoagulants, but there's a picture of a 3 milliliter syringe. So you see it shows you 1/2, 1, 1.5, 2, 2.5, 3. So if you look at the 2.5 mark, there's 4 lines between 2.5 and 3. So 2.5 is 2.5, and then there's 4 marks between 2 and 2.5. So you have 2.1, 2.2, 2.3, 2.4, and if you bring it down to right above the 2.5 mark, which is 2.5, and you just barely have it kiss the 2.5, then you're pretty much at 2.49. So that's how I measure 2.49. I consider it's pretty accurate, but probably you might want to round that to 2.5. So there's another estimating to 2.5 mLs. And that would definitely be measurable on a 3 ml syringe if it was 2.5. Okay?
Okay.
Yeah. So, okay. Okay, so all of the practice problems E, okay, practice problems F on page 269, they don't tell you which ones to use, so you have to decide which method you're going to use to calculate the dose. So looking at number 1 on page 269, these are practice problems letter F. It says round to the nearest hundredth for weight calculations and the nearest tenth when providing volume calculations unless otherwise noted. So number 1, a physician orders milk of magnesia for a 3-year-old child, so we know it's not an infant. The usual adult dose is 30 mL. So this one, you know, there's no weight anywhere, is there? And it doesn't even give you milligrams. What is milk of magnesia?
I think it's used for like a stool softener.
It's well, it's a laxative. I don't think it's a stool softener. I think it's more of a stimulant laxative.
Okay.
It might be a stool softener though. I'm not really sure, but I know it makes them go to the bathroom, right? If they're constipated, milk of magnesia is supposed to, you know, clear them out overnight. Okay, so how would we figure this one out? Which rule would we use?
I think the Young's rule.
Young's rule? Why are you thinking Young's rule?
It's saying child dose, and then you're dividing child's age in years by child age in years plus 12 times adult dose.
Okay, now do we have to have milligrams on the adult dose?
No.
No?
No, we don't have to. It says the usual adult dose is 30 milliliters. So let's go ahead and do this one. You said it would be the child's age over what again?
The age plus 12.
Okay, so 3 plus 12 is 15. And then multiply that by 30 mLs. What do we get?
Six?
6 ml.
Yep, 6 mLs, that's what I get. Okay, look at number 2. Without even working it out, which rule would you use?
The infant rule?
The infant one, which one is that one?
The Freed's rule.
Freed's rule, good. What about number 3? Which one would you use for that one?
Also Freed rule.
Yeah, I would use Freed's on that one too. What about number 6?
Young's. Oh,
Young's
sorry.
rule?
Number 4. Sorry.
Yeah, just like number 4 would be similar to number 1, except we have milligrams, right?
Yeah.
Yes.
Okay. So at the bottom of page 270, it gives you like an overview or a little quick review. Certain populations require special dosing considerations. In all cases, the manufacturer's suggested dosage should be the guideline for the amount of medication. Highly toxic medications also require special calculations for safe and accurate doses. In most cases today, body surface area is the basis for calculating children's doses and chemotherapeutic medications. It's gotten to the point where at the hospital, the patient's body surface area is up there next to their weight and height. So it's already calculated for them. In the past, children's doses were estimated from adult doses based on weight or age using Clark's, Young, or Freed's rule. These methods are not common now. With other medications, the physician may write adult or children's dosages to be given on the basis of the amount of medication per body weight, such as milligrams per kilogram. Okay. The milligrams per kilogram is the general rule, so much so, and this is what we're gonna get into with chapter 13. And I think we should go ahead and start chapter 13. So much so that they start saying, what is the mg per kg? Because they go straight into milligram per kilogram, which is chapter 13, okay? It's just like a normal thing. Now they will use, like I said, they'll use the body surface area mostly for chemo. And we do have a whole wing, not a wing, but a whole unit in the hospital for, peds oncology, which is children's cancer. And unfortunately, we have to have, 25 rooms for children's cancer. It's not full usually, thank God. Okay, so looking at chapter 13, which is page 281. The key words are the day's supply, which are the number of days a prescription will last. This is very important for insurance reimbursement because most insurance companies will only pay for a certain amount of medication based on the day's supply. Most of them will do 30 days like if you walk into your local pharmacy, you can get a 30-day supply of medication for a specific copay. If you want to do mail order or one of their bulk ordering things, then they'll usually give you a discount, like you might get 3 months for a 1 month supply copay or a 2 month supply copay. So you get a discount because they want you to use mail order. because it's cheaper to fill prescriptions in another state where they pay the pharmacists and the technicians less, and they pay less rent on the building, and then, you know, truck it or mail it to another area. It saves them so much money that they give a discount on the copays. Although there are mail order pharmacies in California as well now. Okay, an inhaler is a device used to deliver medicine by breathing it in through the mouth or nose. You can have nasal inhalers. And a nebulizer is a device used to produce a fine spray of medication for inhalation. Most nebulizers have a mouthpiece, so that's going to be an oral inhalation. Let's go over to page 287, which is the introduction. The objective of this chapter is to bring together mathematical skills learned in previous chapters to accurately prepare medication for dispensing, given the information provided on a prescription. In some instances, the medical profession omits the number of doses necessary or the dose to be given from a total dosage. In many instances, because only one element is missing, the pharmacy staff can make the necessary calculation from the prescription without contacting the physician. Okay, so for instance, if it says it's a tablet, PO, TID times 10 days, how many tablets are they going to need?
30.
30. 3 times a day for 30 days is 30, or sorry, 3 times a day for 10 days is 3 times 10, which is 30 tablets. Okay, so that is what is in the middle of example 13.1, which I think looks really long and confusing. That's up to you guys. You can use ratio, it shows you ratio and proportion and dimensional analysis. With prescriptions such as this, most pharmacists will expect a quick mental calculation of the answer because it is simple multiplication. Never forget to use common sense when looking at an answer. If a prescription is written for 4 capsules a day for 7 days, multiplication gives you the answer of 28 capsules. You're using the process of these, you know, dimensional analysis or ratio and proportion mentally. So if it's 1 POQID times 7 days, that's going to give you 28 capsules or tablets, right?
Right.
Okay. So you either have to know the quantity or the amount per day times the duration, which is how many days. So you either have to know the quantity or the day's supply that they're going to be taking it for, okay? Look at the bottom of page 287, example 13.2. A doctor prescribes Cefdinir. Cefdinir's brand name when it first came out was Omnicef, Omni meaning everything, because it's a cephalosporin that is supposed to be good for everything. We don't use it that often, so clearly it's not, it doesn't cure everything. Anyway, the Cefdinir is prescribed 125 milligrams BID for 10 days for a staph infection. The stock strength available is 125 milligrams per 5 ml. How many milliliters are needed for the entire course of therapy? Using dimensional analysis will help keep track of the units. We want to know how many milliliters to give the patient. So if you look at the bottom of page 287, it shows you 5 mLs contains 125 milligrams. They're taking 125 milligrams per dose, 2 doses per day. And they're taking it for 10 days. Okay, so the milligrams cancel, the doses cancel, the days cancel, and you end up with 100 milliliters. Okay, let's say that this drug only comes in a 150 milliliter bottle. You could give them like 75 milliliters or 150 milliliters. This is just a theoretical example. My bottles are always crooked. They've always melted a little bit in the sun. Which bottle would you use? Because you're going to have to give them the whole 10 days supply in a community pharmacy.
$150.
The 150
Yeah,
ml?
you would give them the whole 150 ml bottle. Now, what are your directions going to say then? If they're taking 125 milligrams twice a day, 125 milligrams is 5 mLs. Your directions are going to say take 1 teaspoonful by mouth twice a day or 2 times a day for 10 days. Okay, so they're only going to take 2/3 of that, right? So if that's 50 and that's 100 and that's 150, they're only going to take 100 milliliters of it, right? So they're going to have a little bit left at the end, and they need to know to throw it away because this drug is only good for 10 days anyway. So your auxiliary labels are going to say shake well. I don't remember if this one needs refrigeration. I don't think that it does. I think it's room temperature. So it'll say something like do not refrigerate and discard after 10 days. Okay, does that make sense?
Yeah.
Okay. Now you're going to charge the insurance company though for the whole bottle because they're going to waste 1/3 of it. So you're going to end up, when you choose this, you're going to choose the Ceftonir with the correct strength, which is 125 milligrams per 5 mLs, and you're going to choose the 150 ml bottle, and that's what you're going to charge the insurance company for. Because if it doesn't come in 100 milliliters, you can't give them 100 milliliters. Now, some people could say, couldn't you pour 100 milliliters into another bottle? Yes, you could, but remember, what are you going to do with your leftover 50 milliliters? If you don't have another prescription the same day that you could add to a new bottle and end up with the correct amount, you're going to waste it anyway, right? So chances are good that you're going to end up wasting the 50 milliliters that's left. So you lose money. This is why insurance companies let you charge for the entire bottle and give the patient the whole bottle and put those little auxiliary stickers on there that say discard remainder or discard after 10 days. Okay? All right, let's look at practice problems A on page 289. Let's look at number 2 because it has a lot of questions. I like these. A prescription prescribes Keflex cephalexin oral suspension 62.5 milligrams PO Q6H times 10 days. So they want, let's look at this, 62.5 milligrams PO Q6H times 10 days. Let's calculate how many they would need for the entire course of therapy. So the stock strength is cephalexin 125 milligrams per 5 mLs in a 60 milliliter bottle. And it says once it's reconstituted because these bottles come as a powder and then you have to add liquid. Usually we use sterile water or we use distilled water to reconstitute them. Okay, so the whole bottle is 60 milliliters. How many milliliters do we need for the whole thing? First, we have to figure out how many milliliters is 62.5 milligrams, right? What's half of 125?
62.5.
62.5. So don't we need half of 5 mLs?
Yes.
Okay, let's go ahead and do the math anyway. Let's verify what our instincts are telling us. Five times 62.5 equals divided by 125 equals 2.5 milliliters. Okay, so if they're taking it every 6 hours, how long or how many doses is that?
The total is 60 ml.
No, they're taking 2.5 milliliters, but they're taking it every 6 hours. How many doses is that?
4,
4 doses, and how many days?
10 days.
So how many milliliters is that for the whole course of therapy over the 10 days?
100?
100.
Yep, it's 100 milliliters. So the first question is how many milliliters are needed for the entire course of therapy? It's 100 milliliters, right? How many bottles would need to be dispensed for this prescription? The bottle's 60 milliliters.
2?
Almost two bottles, 60.
Yeah, and remember
bottles.
for outpatient pharmacy, we can't break these bottles. They have to have the whole thing. So, because remember up here, we're just gonna waste it otherwise. So they're gonna get the whole 150 milliliters. So here, the bottle comes as 60 milliliters. So we're gonna give them 2 of the 60 ml bottles. So that's going to end up being 2 times 60, which is 120 milliliters, right? So the answer to the question, how many bottles, would be 2 bottles, right? Now, how many milliliters should be remaining after 10 days? That's where you need to know about the 120 milliliters, right?
Yeah, so 80.
So they're going to use 100 milliliters of it, right?
Yeah,
20.
So how much is going to be remaining?
20 ml.
Okay, then it says what volume of medication should be administered with each dose. We already figured that out, didn't we?
Yeah.
Excuse me, Mrs. Lopez.
Yes.
The 2 bottles is 200 ml. So, and we use 120 ml. So, how much we left, or how much
Wait
extra?
just a minute. Okay, so it says here that the bottle are 60 milliliters.
Yes. We will use 2 bottles of 100 milliliters, so it's 200 milliliters.
Okay, we need 100 milliliters for the whole course of therapy, but there's no bottle of 100 milliliters.
Yes.
It only comes in 60. Let me use my excellent illustration skills. I can kind of color inside the lines. Okay, so we need 100 milliliters, but our bottle's only 60. So if we use 2 of the 60 milliliter bottles, that gives us 120
I get it.
milliliters.
Yeah, I get it. Thank you.
Okay, so So if we use 100 milliliters of it, there's going to be 20 milliliters left over. And what volume should be administered with each dose? That's the 2.5 mLs. What is the dose in household measurements?
Half a teaspoon.
Household measurements for most medications is going to be teaspoons, which is 5 mLs.
Half a teaspoon.
All right, Penn, what are you doing? So a half a teaspoon. And write the directions as they should appear on the customer's bottle. So remember, you always want your verb and your route. I've had to send quite a few homeworks back. You know, I can only give you like 5 points on this 20-point homework because you need to rewrite it with the verb and the route, right? Okay, so I know it's usually people who don't watch the YouTube videos of our meeting later, and then they don't, you know, they don't understand how important the verb and the route is. So especially where you're going to send this home with the patient, you need to make sure that the mom knows, or dad, or whoever the caregiver is, or if this is for an adult, that the adult knows for themselves how to take the medication. So we're going to use the word take, right? Now, if this is for a little child, you can put give. In fact, Walgreens used to automatically, let's say this was for a child named Bijan. So in that case, it would say give Bijan with parentheses around the child's name, which I thought was kind of rude because it almost says, give Bijan, you named your child something weird, a half teaspoon, right? So a lot of companies have stopped using the give. So in this case, we're going to take that part off. And we're going to put take 1/2 teaspoonful. And what's the route?
By mouth.
By mouth.
By mouth. And how often are they supposed to take it?
Every 6 hours.
Every 6 hours for 10 days. And what are we going to put on there again, since we had to give them a larger bottle?
Discard remainder.
Discard remainder. And then it's also going to have, this particular drug is 14 days, so it's going to have a best use date or an expiration date of 14 days. Okay, so whatever today's date is, today's the 15th, so we would have our best use date. If we were to fill this today, it would say 10/29/20. Okay, now the best use date really has nothing to do with the fact that they're only going to take it for 10 days. We just want them to make sure if it's still in their fridge after 14 days to toss it, right? So that is our auxiliary label. Okay.
Father, I think your mic is on. Sorry, it's distracting.
Okay. Okay, the rest of this chapter gives you some of the similar type things for patches, for and it gives you labels or prescriptions. So let's look at number 3 on page 290. It says a physician prescribes, okay, tell you what, let's do number 4 instead. No, let's do number 3. I like 3. A physician prescribes nitrofurantoin. Nitrofurantoin is also known as Macrobid or Macrodantin, was the generic or the brand name for that. It's been around a really long time. It's a urinary antiseptic. It's not necessarily an antibiotic, so you can't take it for other things. What it does is it cleans the inside of the bladder and the urinary tract, so it helps flush out things that shouldn't be in there that cause infection. And they need 0.1 grams. QID, it's PO, so it's going to be probably a capsule. Yeah, it says capsules. PO QID for 7 days for a urinary tract infection. The stock strength is nitrofurantoin 50 milligram capsules, 50 milligrams per capsule. How many capsules are needed to fill this prescription? Okay, so we have grams here, and we have milligrams here, right? So how are we going to figure out how much to give them?
We would have to convert into milligrams.
Yeah, because the capsules come in milligrams, so we should always convert from what was prescribed to what we actually have in stock, right? Okay, so it's prescribed in grams, but we have milligrams. So what's my conversion factor?
It's 1,000 milligrams per 1 gram.
1,000 milligrams to 1 gram. 0.1 gram is my dose. So I'm going to move the decimal point over to the right or the left.
To the right.
Yeah, I'm going to move it to the right 3 places, right? Well, actually yeah. So 0.1, and if I move it to the right, 1, 2, 3, or I could punch it in my calculator and we get 100 milligrams, right? Okay, so I need to give 100 milligrams, but there's 50 milligram capsules. So how many capsules is that?
2.
2.
2 capsules. So I'm going to give them 2 capsules times, how many times a day?
4,
Times how many days?
7,
How many capsules is that going to be?
56,
So I'm going to give them 56 capsules. So how many capsules are needed to fill this prescription? There's your answer. And then what directions? Write the directions as they should appear on the customer's bottle. So what's my verb here?
Take.
take,
Take. Take 2 capsules. What comes after that?
By mouth.
By mouth.
Four times a day
4 times a day.
for 7 days.
Good. Okay, so those are the directions for the patient. Okay, number 4 says interpret the following prescription. Now, interpreting it doesn't necessarily mean who's the doctor, who's the patient. We want to know about the drug that's ordered and how to take it and how much, right? So Let me go back to, let's go back to, ooh, a dark purple this time. How would you interpret that prescription? What is that drug?
3 tablets by mouth twice a day.
Okay, let's look at trileptal. Let's see what that is. I'm going to look it up in my handy dandy drug handbook here. Or you could Google it. That's fine. I like books. I like the way books smell, especially when they're brand new and you can smell the ink. You guys already know I'm a little odd, so that's okay. Tranxene, Travatan, Tretinol, Trileptal, 1058. Looked in the index and now I'm going to page 1058. And it is oxcarbazepine is the generic. Oxcarbazepine. This is an anticonvulsant, so it's for seizures or epilepsy, right? Okay. And it's 150 milligrams per tablet, right? Oh, come here, you. So they're getting 3 tablets by mouth twice a day. And it wants to give a 1 month supply. So how many tablets are we going to use to fill this prescription?
180.
180. Yeah.
3 tablets twice a day times 30 days. 6 times 3 is 18. 180 tablets. Good. How many milligrams are they getting a day? It's not on here. It's not one of the questions, but how many would they be getting?
450.
450, but twice a day, right? So
Yes,
that would be 900
900.
milligrams per day. And that's just a little side thing there where they're not actually going to ask. I mean, they didn't ask you that question, so. Okay, let's look, we already did a Keflex one. Let's look at page 291, number 6.
What
During
number,
a
please?
severe influenza epidemic, a physician writes the following prescription as a prophylaxis. What does prophylaxis mean?
Like preventative measures.
Exactly, it's prevention against a secondary bacterial infection in an older adult with COPD. What is COPD? It starts with chronic.
Yeah, chronic obstructive pulmonary disease.
Very good. So pulmonary disease is in the lungs. So this patient already can't breathe. If they have a severe flu epidemic, that can cause phlegm in the lungs, coughing, sneezing, that kind of thing. People tend to think of the flu as something that makes you throw up, right? Influenza doesn't really have anything to do with your GI tract. It causes headache, chills. Some people get nausea with it. I just completely lost my appetite. I had swine flu in 2008. Nothing tasted good. Everything was all ugh because I felt so crappy. I had a fever and then I would go down and I'd have chills and then this fever would spike again. I had body aches and coughing and upper respiratory stuff. So if the patient already has COPD and they can't get the phlegm out as it is, then that phlegm can actually grow bacteria and they could end up with either pneumonia or what is that where you get bacteria in the lungs and it's hard to breathe and you're coughing crud out of your lungs?
Well, like emphysema or,
Not emphysema.
yeah, because usually chronic obstructive bronchitis, emphysema, asthma.
Bronchitis is the word I was looking for. Yeah, they can have bronchitis, which is swelling in the lungs. So anyway, they want to use this as a preventive. So you're interpreting the order, and it is amoxicillin, (500 milligrams) twice a day for how long?
10 days.
10 days, yes. Now, the only amoxicillin in stock, because we're in the middle of an epidemic, that's kind of funny because we are, the only amoxicillin in stock is amoxicillin 250 milligrams per capsule. So how many capsules should be dispensed to the patient to complete this order? So
40.
is 250 milligrams per capsule. So how are we going to do that?
40 because 250 times 2
Okay,
times 10.
so they're going to take 2 capsules twice a day for 10 days. So what do we get with that?
40.
40 capsules. Good.
If it's 250 milligrams, wouldn't they be taking 4 tablets a day?
Well, they need 500 milligrams twice a day. So yeah, they would be taking 4 capsules a day, but they're just going to take 2 capsules at one time. So the directions that you're going to write on the customer's bottle are, again, take 2 capsules, and we always need a route by mouth 2 times a day for how long?
10 days.
10 days. Okay. So 2 capsules twice a day for 10 days. 2 times 2 is 4 times 10 is 40. Okay, so we've been going for 2 hours and 18 minutes or so. How are you guys doing? Do you want us to pick up chapter 13, the rest of it next week?
Yeah.
Yes, please.
12 requires a lot of thinking over, don't you?
Yes.
Yeah.
Okay.
Doggies are jumping all over me.
Okay, so I'm going to stop here. Do you guys have any questions on chapter 12?
Not yet because I didn't study it yet, so.
Okay, yeah, chapter 12, I think, is one of the more involved chapters in the book. I really do. I think chapter 12, and then when you get over to chapter 14 and 15, or 15 and 16, yeah, 15 and 16 are, I think they build on this. So the day's supply calculations, what we've done for chapter 13, I don't think is super difficult. Do you?
Oh, 13 is easier than 12.
Okay.
I agree
That's
with Sajid.
getting, and that was my idea on it too. So I think we're going to stop here so you guys can go back over chapter 12. I'm going to see if I can get this thing to post today to YouTube, because I don't think I'm going to need to edit it. So I think I'm just going to go ahead and post it, and then you guys will have this to look over, and then just That's chapter 13. So here's chapter 12. So let me know if you guys have any questions, okay?
Yeah, now that 12 is
Mrs.
not due.
Lopez, please. Oh, sorry, Marble. Go ahead.
Yeah, 11 is due next week, correct?
Yeah, so it's due next week, but I've been giving you guys 2 to 3 weeks to complete these because I know a lot of people, are still working or they're homeschooling their kids or whatever. And so I haven't been taking points off for being late. I'm more likely to take points off if you don't give me a route and a verb, okay? That's extremely important. Where it says for the patient's label, it has to have a route and a verb. Okay?
Mrs. Lopez, please, can you open the submission for chapter 11?
Is it not open yet?
No.
No,
Okay.
it's not showing
I'll
anything.
open that up too for you guys.
Thank you.
And if I have questions on 12, we have at least till next week to.
Okay, what was that, Maribel?
No, I said I'm gonna look over 12. If I have questions, then I'll address them next Thursday.
Okay, great.
Ms. Lopez, real fast on this VSA equation,
Yes.
that 3.131 or 3,131?
It's 3,131, which I probably shouldn't have even tried to draw the comma. So let me take that off. Yeah, it's just 3131.
Okay.
Yeah, because it's confusing if you see the comma, because I didn't put it over here for 3,600, so yeah.
Oh, and then
So
just the
it is
side note.
3,131, but you're not going to type the comma in your calculator, so there you go.
Sorry, Professor Lopez, for the problem that you did for page 290, number 4.
Okay, let me go down to 290. Number 4, okay.
Okay, that kind of just threw me off a little bit. Just want to confirm. So the side note that you did there, the 900 milligrams, that's because the patient's taking 450 milligrams per day, but they're taking it for 2 days. So that's times 2, the 900. Is that what that is?
Yes, because
Okay.
that tells you how many milligrams they're taking per day. I threw that in there because sometimes you'll get asked that on different problems.
Got it. Thank
But-
you.
Yeah, but it's not in your question, so you can pretty much disregard that if you want to. Okay, anybody else have any other questions?
No, thank you.
Okay.
Thank you, Professor.
Thank you so much for showing up, you guys. I think there's a reason why your scores are reflecting that. So you guys are doing pretty good. And I like talking to you. So I want to do some more of these types of sessions in the late afternoon or evening so I can catch some of the people who work all day and aren't able to tune in. So I'm going to see when I can schedule that. So we'll see what happens for your co-students who can't show up for this.
Okay.
Okay. Thank you so much, and I'll see you next week.
Thank you,
Bye.
Professor.
Thank you.
Thank
Bye.
you.
Bye-bye.
And
Bye.
you're gonna open chapter 11 submission, right?
What's that?
You're gonna open up chapter 11 submission for submission?
Yes, I'm opening it for submission today, as soon as I get off of here.
Oh, thank you.
Thank
Thank
you.
you.
Professor, this is Maribel. So I hear you mentioned you're wanting to do an evening class?
Well, it's not going to be like an evening class. I want to schedule a few of these Zoom meetings for people who work during the day.
Okay, I'm glad you mentioned that because I work for school district and they're thinking about going back on the 26th.
Okay.
Which would put me at school from 9 to 3.
Okay.
So I'll let you know for sure. I'll try to see if the teacher, she's really nice. So
Okay.
if she's willing to work out with me from 2 o'clock. But if you do an evening class, I'm more than happy to join.
Okay. What I want to do is send out an email and just see who's interested, because if I can get at least 4 or 5 people to show up, then I'll do it.
Okay, now, another thing, I do have a medical terminology class from 5:30. That's the thing. So would it be on a different day?
I can do it on a different day, yeah.
Okay, that would work out great.
Marble, but we will miss you here.
No, because I'll still be here.
I'm gonna try really to try and stay on the 2 o'clock because it works good with my schedule, but if I go back to work, I have to
Right,
rearrange.
right. No, I would have to add it in because obviously I can't make you guys, you know, I don't know, some of you guys may go to work right after this or go to work at 6 p.m. or something or 7. So I don't want to change this standing meeting because it's working so well for this class, but
Yeah.
I would add a short session on a different night just so I could catch some other people as well. So,
No, I will definitely let you know by the 26th.
okay.
Okay.
What evenings would work for you, Maribel?
Any other day besides Thursday. I only have classes on Thursday right now, which is your
Okay.
medical term.
Okay, great. Oh, so that's how you know the medical terms.
Right.
Very nice. Cool. All right, thank you. I'll talk to you guys next week then.
Thank you too. Have a good week.
You too. Bye-bye.
Volunteer too late, 'cause, you know what I mean?